So welcome to this latest video on 162 Maths, and in this video we'll be going over the AQA AS Maths paper of May 2022, paper 2, section B, which is the statistics section. Now as always, I'll include a question breakdown in the description below so you can see which question refers to which topic. So let's get started on this May 2022, paper 2, section B, which is the statistics section. So looking at question 11, it's looking at box plots, and it says which of the terms below best describes the distribution represented by the box plot shown in figure 1. Please circle your answer. So again, not much thought needs to go into this one, but the correct answer is negative skew, as the median is more towards the upper quartile than it is the lower quartile. Then for question 12, it says Shelley organised an activity weekend for 15 groups of 10 people. She decided to collect a sample to obtain a feedback about the weekend. To collect a sample, Shelley selected 2 groups at random, then interviewed each member of these 2 groups. And it says state the name of the sampling method that she did. Now for this one, it may seem quite controversial, but it's going to be cluster, simply because she just picked the 2 out of the 15 groups and that was it. Then moving on to question 13, it says 2 random samples of 12 NOx emissions were taken from the large data set. One sample was taken from the 2002 data and the other sample was taken from the 2016 data. The sample data is shown below. The mean and standard deviation of the 2002 sample data are 0.122 and 0.137 respectively. Find the mean and standard deviation of the 2016 sample data, giving your answers correct to 3 decimal places. So for this, it's only the 2016 data that we're looking at. So for this, all we need to do is just simply plug this into our calculator and let it do all the hard work and find the mean and standard deviation. So if you've got the Casio calculator, all you need to do is go to menu, then go to statistics, then enter one variable, and then once you've selected that, what you then want to do is enter the data. Now when you're entering the data, do make sure that you are making sure you've entered each value correctly, and it's definitely worth, once you've entered all those 12 values, is just double check. Now don't worry if your calculator gives your on the display your number in standard form. It's just the way that the calculator handles certain numbers, so don't worry too much about that. And once you've done, then press the option button on your calculator, and then you want to select one variable calculation. And once you've done that, you should be able to find that the mean, which is x bar, gives you a value of 0.026, and that's to 3 decimal places. And the standard deviation, well, you can either use sigma or s, in which you'll have an answer of 0.021 or 0.022. Now in the mark scheme, they have accepted both of those answers, so either of those 2 would be fine. Moving on to 13b, it says City claims these samples show that an average of the NOx emissions across all makes of cars in all areas of the UK have fallen by over 75% between 2002 and 2016. Show how City's claim of over 75% has been obtained. So let's have a look at this. So in terms of looking at a percentage, you want to look at the difference divided by the original multiplied by 100. So here we want the difference between the 2 means. So the difference between the 2 means, which if I go back is 0.122, and the one that I've just calculated for part A, and so that's going to be 0.122 minus 0.026 divided by the original, which it was in 2002, so that's going to be 0.122, and we're going to multiply that by 100. Now if I type that into my calculator, I get an answer of 78.7%, which is greater than 75%. So there we go. Then moving on to 13b, it says using your knowledge of the large dataset, make 2 comments on the validity of Sithi's claim. Now again, there's a couple of answers in which you can do in terms of comparisons, and depending on your memory of the large dataset, particularly this section, but something along the lines of a typical answer would be that the large dataset only includes a limited number of makes, not all makes, and the large data set only includes a few areas, not all areas, which is what she initially claimed. Moving on to question 40, it says Yingtai visits her local gym regularly. After each visit, she chooses one item to eat from the gym's cafe. This could be an apple, a banana, or a piece of cake. She chooses an item independently each time, and the probability that Yingtai chooses each of these items on any visit is given by, the probability of an apple is 0.2, probability of banana is 0.35, and probability of a cake is 0.45. For any 4 randomly selected visits to the gym, find the probability that Yingtai chooses, and it says at least 1 banana. Now for this, if you thought about it long term, so it could either be any 4 but it can't be a banana, or at least you need to have at least 1 banana rather, there's going to be quite a lot of combinations. So it's much easier in this particular case, especially for 2 marks, to find what you don't want and take that away from 1. Now the thing that we don't want is the probability of basically no bananas. So this here is going to be the same as the probability of 1 minus no bananas. Now the probability of no bananas on 4 separate visits, well, the probability of no bananas is going to be 1 minus 0.35, which is 0.65. So then for this, the probability of on any given 4 of at least 1 banana is going to be 1 minus 0.65 to the power of 4. And if I type that into my calculator, I get the answer of 0.82149. And there we go. Now if you want to give a rounded answer, that'll be absolutely fine, but always state what you've rounded it to. For 14b, it says the same item each time. So for this, we can either have 4 apples or 4 bananas or 4 cakes. So the probability of selecting an apple was 0.2, so 4 of them is going to be 0.2 to the power of 4. And again, if you're not sure why it's the power of 4, because you want A and A and A and A, which is 0.2 times 0.2 times 0.2 times 0.2. And all means plus. For bananas, well, the probability of picking a banana is 0.35, so that's going to be to the power of 4, because again, B is going to be 0.35 times 0.35 times 0.35 times 0.35. And then all 4 cakes, well, probability of selecting a cake is 0.45, and that's again going to be to the power of 4. Then if I enter all of this onto my calculator, I get the correct probability of 0.0576125. And again, if you want to round your answer or give the exact answer, that's entirely up to you. Then moving on to 14b, it says work out probability of an apple twice and a cake twice. So if you look at the combinations of apple and cake twice, we can have A, C, C, and then A, C, and then A, C, A. And then we can also then have C, A, in which we can then also have C, A, and then C, A, C. So there are 6 possible combinations of having apple twice and cake twice. Now in terms of working out the probability of each of these 6 lines, that they should be identical. So the probability of an apple is going to be 0.2. Let me just make sure that is the case. Yep, 0.2. So this is going to be 0.2 multiplied by 0.2 multiplied by 0.45 times 0.45. Then the second row is just going to be a different the same numbers but multiplied in a different order. And then moving on to the next set, that's going to be exactly the same. And then all we then need to do is just simply add together all those probabilities. So ultimately what you'd end up with is 6 times 0.2 squared multiplied by 0.45 squared, which gives us an answer of 0.0486. Then moving on to question 15, it says the discrete random variable x is modelled by the probability distribution defined by, and we've got our probability function there where k and c are constants. State in terms of k the probability that x is 3. Well, when x is 3, I need to use this function here. So here, when x is 3, we have k times 3 squared, which is 9k. And there we go. Then for question 15b, it says given that the probability of getting greater or equal to 3 is equal to 3 times the probability that x is less or equal to 2, find the exact value of k and the exact value of c. Well, first things first, let's draw our probability distribution. So I've got x and it's certain values of 1, 2, 3 and 4, and let's work out the probabilities of each of those. So then substituting the values of x into those respective ones here, which I don't think I can fit on, just about fit on the screen. So the probability of getting a 1 is when x is 1, so that's going to be 1c. Probability of getting 2 is going to be 2c. 3 I've already worked out as being 9k, and 4 squared, which is 16, so that's going to be 16k. Then from this, what I then need to do is then work out the components of these. So here the probability of x being greater or equal to 3 is basically adding these two things here, so that's going to be 9k plus 16k, which is 25k. And the probability that x is less or equal to 2 is going to be this plus this. It's going to be c plus 2c, which is 3c. So then joining these two components into this line here, so if probability that x is greater than 3 is equal to 3 lots of probability that x is less or equal to 2, substituting those two things in, I get 25k equals 3 times 3c, so 25k equals 9c. Now just for the time being, I'm just going to put a little box around that because I need to work out what k and c is. Now in order for me to work out the answer of two variables, I need two equations. So again, working with a probability distribution, you should also always remember that the sum of all of the probabilities adds up to 1. So to get my second equation, I know that 3c plus 25k equals 1. Now if I make 25k the subject in this green sort of equation that I'm writing here, so I have 1 minus 3c, and just put a box around that, you can see how in these two equations I've now got 25k the subject. So if I substitute one into the other, then what I find is that I've got 9c equals 1 minus 3c, which therefore means that 12c equals 1, so c equals 1/12. Then if I know that 1/12, c equals 1/12, then 25k equals 9/12, so k equals 9/12 divided by 25, which on the calculator gives me an answer of 3/100. So my value of k is 3/100, or 0.03, and c equals 1 over 12, which as a decimal is 0.08, or 0.08 I should say, 83 recurring, but personally I would leave it as a fraction. Then moving on to question 16, it says it is believed that a coin is biased so that the probability of obtaining a head when the coin is tossed is 0.7. Assume that the probability of obtaining a head when the coin is tossed is indeed 0.7. Find the probability of obtaining exactly 6 heads from 7 tosses of the coin. Now hopefully the fact that it says exactly kind of implies that this is going to be a binomial distribution question. So first of all, setting up the parameters of b, and we've got a total sample size of 7, and the probability of success is 0.7, and we want the probability that x is equal to 6. Now if you've got the Casio calculators, if you go to menu, then go to distribution, then go to binomial, and we want PD because we want the exact values. And let me just double check to make sure that that is the path, and yep, and we want variable. Then if I set up my parameters of that x equals 6, n equals 7 and p equals 0.7, I should get the correct answer of p equals 0.24706. Then for 16aii, it says find the mean number of heads obtained from 7 tosses of the coin. Well, the mean on a binomial distribution is np, so then it's going to be 7 times 0.7, which is 4.9. Then moving on to the very last question, it says Harry believes that the probability of obtaining a head for this coin is actually greater than 0.7. To test his belief, he tosses the coin 35 times and obtains 28 heads. Carry a hypothesis test at a 10% sig level to investigate Harry's belief. So first things first, let's set up the null and alternate hypothesis. So the null hypothesis is always that the probability is what it claims to be and what it was originally, and the probability that the alternate hypothesis will be Harry's claim is that it should be higher than 0.7. Once I've got this, I then need to establish the fact that it's a one-tailed test. I'm looking at a 10% sig level, and I'm going to be testing using a binomial distribution where the sample size is 35 and the probability of success is 0.7. So all that's left for me to then do is then work out the test statistic, and which I can't spell, so let me just try that again. So the test statistic, again I'm not even knowing what I'm writing, there we go, is therefore going to be the probability that x, and again it's always the same direction as the alternate hypothesis, is going to be greater than 28. So this is what I then need to work out. Now if you're using a calculator, your calculator only gives community values over less than that, so we can then do that. It's going to equal the probability that x is less or equal to 27. So then on the calculator, to find this number here, I go to menu, distribution, I go to binomial CD, I click on, let me just quickly do that on the calculator as well. So binomial CD, go to variable, and then the parameters are going to be n equals 35, x equals 27, and p equals 0.7. So once I've pressed equals, I should get the probability of x is less or equal to 27. So let me just enter that in now, and I get 1 minus, and this answer here is 0.86735, and it carries on, but you take that away from 1. So then if I do just that, I get an answer of 0.013265, or a number that's roughly around there. So then all that's left for me to do is then come to the conclusion. So as 0.0132 is greater than 0.1, we accept HO or reject H1, whichever floats your boat. And the fact that there is sufficient evidence at a 10% sig level that the probability of getting ahead is still 0.7 or not changed. Something along those lines would be good enough to get all marks for this particular question.